This is fantastic. Hey, thank you for putting this on. Thank you everybody for coming. This is going to be a great day. I've brought down some great speakers. We're going to cover some really interesting topics. It's really good that you're here. I see some familiar faces. I see some new familiar faces, and we brought down some new familiar faces for you. My name is Jeff Bisti. I work in the Poughkeepsie IBM, like an hour, 8 minutes, I think Waze said, north of here. I've been there for almost 18 years now. And if you had told me back when I was in high school that I was going to work for IBM for 18 years, I would have said, no way, no way. Like, you must be thinking of the other Jeff. This is a small high school class. There's no way I want to work at a big company like IBM, and there's no way I'm going to be at any place for 18 plus years. Like, I need to see new stuff all the time, or I'll just get fired, because that's happened before too. So there's no way that's going to happen. But at the same time, I knew that I wanted to get into computer stuff. I wanted to do information technology. I was always fixing people's computers, but that's not what I wanted to do like full time. It seemed like a miserable thing to do. I knew that I could like write my own little programs to do things that I wanted to automate, but I couldn't write something that somebody else wanted me to do. Like, I would never be happy handing over to someone else. But I knew I wanted to get into computers somehow. So I went to Marist College in Poughkeepsie, right next to IBM, with an information technology degree. Again, not straight up computer science, because I didn't want to spend all my time writing code, but I wanted kind of like a broader picture there. And a little bit about Marist College. Back when I went to college, and I'm old enough where I can say that now. Back when I went to college, we didn't have wireless. There was no wireless internet. We didn't even have Ethernet to plug into. We had something called token ring. Yes. Who's ever heard of token ring? Yeah, I'm noticing a pattern with the hands. Okay. So who knows what Ethernet is? Okay. Back before Ethernet came like the standard for wired networking, there were a whole bunch of different standards for that. And one of IBM's was called token ring. And it's one of these things that's, might be technologically better, but for whatever reason, for a number of reasons, it didn't catch on. But Marist College had token ring all throughout its campus. And if you were in a dorm room with 2 or 3 people, you had 1 or 2 token ring jacks in there. And you couldn't plug it into like, a token ring switch and break it out there. I mean, you could, but these token ring switches were like $600. We looked into it. So if you had 3 people in a room with 2 jacks, or you just wanted to work in your friend's room, you had to disconnect from the network, which, back in late 90s, early 2000s wasn't as huge of a deal. It wasn't quite as expected that you'd be on the internet all the time, but it was still kind of annoying. So eventually one of our friends kind of came up with a plan. And they said, hey, you know what? I figured something out over like Easter break or something like that. If you take like a computer, just like the cheapest computer you can find like a 486 that's on the curb that somebody's throwing out with like a beige case and a turbo button on the front of it, oldest computer you can find, throw your token ring card in that, the big old honkin' ISA token ring card, and plug that into the network. So get that cheap machine on the network, and then plug another Ethernet card in there. So it has 2 network cards. And install this weird operating system called Linux. We're not sure what it's all about, but this operating system called Linux. Who's heard of Linux? At the time, you wouldn't see as many hands. That's good to see, though. So we'll install Linux on this thing. And we can kind of turn this cheap computer into a network router, because it can talk token ring and it can talk Ethernet at the same time. We can turn it into a router. And then we can plug that Ethernet card into an Ethernet switch, or more likely a hub, because switches were like $80, hubs are like $20. And then we can plug as many computers as we want into this hub. So now it's not just 2 people in a room that can connect to the network, or 1 person with 1 computer. We could bring in all the other computers and devices and plug them into this Ethernet switch. So that's how we got around having 2 token ring jacks per room with 2 or 3 people. It also meant that we could go out and buy a wireless access point and plug that into our Ethernet switch. So now, 5 years before it got implemented, we could have wireless Ethernet in our dorm rooms. And that was just, it was a huge deal. And I'm mentioning this because what we didn't realize at the time was we were learning something. And when you're learning something and it's right, when you're doing learning right, it feels like you're just figuring something out or you're just playing. It really felt like we were playing. But what I didn't realize is I was learning all about networking. I was learning all about Linux. I was kind of having fun doing it, but we had to do it in order to get like our PlayStation on the network. We had to do it, let's talk about what's real here, So what I want to talk about here today is the idea of taking the next step. You have a great idea and you want to make it into something, and you have to make this great idea and take the next step. We went from like sketching out how this whole token ring Ethernet switch hub thing would work. We said this should work technically. We all got together and tried to figure out IP tables and IP NAT and all those modules. We finally got it working. But that's how we took this idea from this thing to the next step. Now, around like late junior, early senior year, I started thinking like, oh, wait a second, I'm about to graduate from college. I'm going to need like a job and stuff. But I still hadn't figured out really what I wanted to do yet. And at the time, I had a subscription to Wired magazine, a print subscription to Wired magazine. And I haven't been able to find this article ever since. I think it might have only been in the print version. But there was actually an article in there about UPS, your friends at UPS, about all the computer systems they have and how they run all of their business. And up until I read that article, I'd never really thought about what it takes to run a worldwide business. That what they were talking about was actually bigger than what could fit on the biggest computer I had ever seen, which at the time was like something like maybe like this big. My computer was that big. I've seen computers that big. Those must be like really fancy. So I'm like, how would something like that even run? Because they're talking about worldwide package tracking for any package in the world, today, tomorrow, the next day, everything for the rest of the year, stuff that's in flight, stuff that's getting picked up. And it can't ever go down, and it needs to be available from any computer at any time. Like, that's massive. I've never seen, let alone written, a program that big. How would you even start to address that? And towards the bottom of the article, it starts to say, and UPS runs a lot of their stuff on IBM mainframes. And maybe it talked a little bit more about mainframe, but I hit the bottom of the article. I'm like, okay, well that's all I know about mainframe right now. I'd kind of like to know more, but article's over. So I kind of filed that away in my brain. I said, okay, mainframe, big computer, can run interesting and important things. And I put that away. And then, as luck would have it, somebody from IBM came to Marist to talk about jobs and stuff like that. And we were talking a little bit afterwards, and I said, you guys do those mainframe things, right? He goes, yes. I'm like, is that like the stuff that UPS runs? Yes. Do you want to know more about that? Yes. So we really got to talk about the idea of enterprise computing and the idea of, and how could a program be so big? And he kind of explained the idea that, it's not just a program, it's all these components that work together. And you can't think of it as just like a thing that you double click and launch. It's a solution that runs all the time. So we got to talking, started exchanging emails, and I said, hey, I'm just spitballing here, but like, do you know about any jobs over there? Because I'd really like to have a job. He said, well, are you interested in mainframes? I'm like, yeah. He said, what else do you know? I'm like, Linux and networking stuff, as luck would have it. And he goes, okay, well, I'll set you up with a job interview in a department of IBM where they do testing of the network devices for Linux on mainframe. Well, that sounds perfect. So that was my first job, my first full-time job at IBM. I got to test Linux device drivers for OSA adapters on the mainframe. And those opportunities only came to me because I kind of took like the next step in thinking to acting. It's kind of a theme we're going to see today with a lot of the technology is that it started out as an idea or a problem, and eventually somebody or a group of people said, how do we fix this? How do we take it a step further? And ideas, ideas are kind of interesting things. You start with an idea, and you have to do something with it. Eventually, it just won't leave your mind. It kind of gets stuck in there, right? It's like a foreign body lodged in your mind, and you're like, what am I going to do with this? Do I try to force it out? Do I convince myself it's a bad idea? or do I start acting on it? Who here has ever had an idea? I better see a lot of hands. All right. Ideas, it doesn't have to be a good idea. But you've had an idea. And ideas really are a blessing. If you've ever tried to make an idea happen, you can't will it into existence. You sit there like, all right, I just need a good idea. So I'm just going to sit here and wait for it to hit me. Nope, nothing yet. All right, I'm going to try another 5 minutes. It's like surfing. Like, you can't make a wave happen. You can only be prepared for it and be ready to act upon it. And what's funny is these, all great things, good things, they start with these ideas. And we know this. This is obvious. You have to act upon them. But a lot of times we treat ideas like it's a curse, and we try to get rid of them because we know that the next step is usually work. I mean, IBMers, we know about this around if you're scheduled for an hour meeting, around 55 minutes in, somebody is going to say, all right, what are our next steps on this thing? Because everyone's convinced it's either something that we should do or something that we have to do. All right, what are the next steps? What's everyone going to do? And it's kind of reluctant, because that's when the real work comes. And that's when people say, you know what, I'm really busy, or I have vacation planned. But that's also where the people who are going to really help you step forward. So that's when the people say, you know what, I am excited about this. I am going to help you with it. But it's really funny when you get an idea, and you know it's a good idea, but you want someone to be like your cheerleader. You want them to help push you a little bit. So you go to your friend and you say, hey, you know what? I had this really stupid idea yesterday. You want to hear this stupid idea I had? You know how blah, 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 blah. What if blah, 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 blah. And you really hope they're going to go, you know what? That's not a bad idea. And you're going to, I know, right? It's such a great idea. It would mean that we could also do this, and it fixes this and this and this. And at the same time, if they were to turn around and say, yeah, you're right, that's a stupid idea, you'd go, yeah. And then you'd go find another friend and go, hey, I got this stupid idea. Because you want that support. You want to give them the out before they'll start supporting you. There's this great comedian. Anybody ever heard of this guy, Mitch Hedberg? All right, he's on Spotify. Do yourself a treat, listen to either of his albums. They're both good. I love this quote of his because it talks about motivation and ideas. And you probably already read it by now, but I write jokes for a living. I sit at my hotel at night and I think of something that's funny. Then I go get a pen and I write it down. Or if the pen is too far away, I have to convince myself that what I thought of ain't funny. Gets these great ideas, and you have to take them to the next step. It involves some work. And in this case, very literally, it means getting out of bed and finding that pen. And I love this because it is so relatable, but also we lost Mitch Hedberg, I think, early 2000s to an overdose. And he has 2 really good albums. And I think that if he was able to, well, first off, not overdose, but secondly, get himself out of bed and find that pen and write some stuff down and take action, be a little more motivated and act on those great ideas he has, we would have had a whole lot more Mitch Hedberg jokes. And maybe that's coming off as a little bit selfish, because I want to laugh at some more Mitch Hedberg jokes, and I'm not trying to turn comedy into tragedy, but I do come back to this quote a lot, is I think of myself as when I'm not acting on an idea or something that I think is a good idea, I'm saying, is this one of those moments where I just have to, I'm convincing myself not to get out of bed? Because it does happen. So what is your next step? When you have these ideas and you finally convinced yourself, okay, I'm going to act on this thing. Hopefully you're going to be able to talk yourself into taking action. But sometimes there are detractors around you. People who say stuff like, don't change anything, that's just how it is. That's just how it is. You don't understand the world yet. You're trying to do something different, and that's just not how it is. Or maybe they'll say something like, hey, let's not try and boil the ocean here. Maybe you've heard that. And this is a really fun one, because if you really think about what somebody's saying there, they're not saying your idea is a bad one. They're not saying that it's not possible. They're just saying, you're talking about a big idea. You're not a big idea person. Think of some small ideas. I don't think you're capable of having a big idea here. There's no need to make things any more complicated than they already are. which is another fun way of saying, like, you know, I just spent a whole lot of time understanding things the way they are right now. Maybe I'm like 5 years from retirement. Maybe I just don't really care, but I don't want to learn another thing. You know, let's not make things any more complicated than the way that I already understand them. Or this is my favorite. You have a great idea, but if that were possible, somebody else would have done it by now. So don't even bother trying that. And this one's especially fun because part of, you know, what I do at IBM is I get to work on patent teams. I get to write up inventions. I get to submit things. I have a couple like actual inventions out there. So we're constantly presenting stuff in front of patent review boards and reviewing things with patent lawyers. And I just think about like how fun it would be if a patent lawyer came back and said, you know, that's a great idea. That would really benefit the world. But you know what? If it was like really that great, somebody else would have thought about it by now. So what's really interesting about all these excuses and like, you know, the thousands more that you can possibly think about is that they all result in doing little or no work, right? The action that somebody wants you to take is to not do anything at all. It's never like, yeah, I guess we have to do that. We have no choice but to act upon this. It's always the smart thing to do is no work at all, right? And maybe you're worried about like using up your good idea. Maybe your good idea, like in my spare time, I've played in a bunch of bands, some originals, some covers, and sometimes an idea for a song hits you in the middle of the night. And it might be a piece of a lyric, it might be a chord progression. One time I woke up in the middle of the night and I was motivated by that Mitch Hedberg quote to write down, no, actually I hummed into my phone this piece of a song that I thought was great. And then when I woke up and I listened back to it, it was a 98 Degrees song. Weird things happen when you're dreaming in the middle of the night. So not all ideas are great, is what I'm saying here. But don't be afraid about using up that one good idea. I guarantee you have more than one good idea in you. Because once you really start working on that idea, you know, that song, that patent, that idea for an app, that, you know, program you want to run, whatever you want to do, you're going to find, wait a second, I have another idea. It doesn't fit in here. It's over here. And you're going to find 3 more ideas behind that one and 3 more behind that one. It just keeps on going. And people think that like you can eventually use up all your ideas and you won't have any left. It doesn't work that way once you start thinking. But we are on a continuum of technology and development. People think that like eventually we'll just get to the future. And then it's, hooray, we made it. We're at the end. We're at the future, right? We made it all around the board, and we're at the future. We are on a continuum. And I like to think about like the most high-tech, this thing impresses the heck out of me. The DJI Mavic drone or a quadcopter, I don't want to get yelled at by my friends who fly these. Look at like the stats on this thing. It weighs 250 grams. That's incredibly light. 30 minutes of flight time. Now, I used to fly like model airplanes and helicopters and stuff like that. The idea of an electric vehicle flying was, you couldn't do it. Because in order to have enough power to move the motor, to move the blades, to get something off the ground, you needed a battery so big that it wouldn't be able to get off the ground. So advances in lithium-ion batteries, something brand new, different types of chemical batteries, brushless motors, make them ultra-light, ultra-efficient. So I can now not only get this thing off the ground, but off the ground for 30 minutes. That's pretty impressive. I'm going to transmit HD video from 4 kilometers away. That used to take an antenna the size of this building, right? Go through all the sensors here. GPS, that used to be something about the size of this table. If you were to show this, or the device itself, to somebody from 25 years ago, their brain might literally overheat and explode. This would be like alien technology. They said there's either I'm misunderstanding you or I'm having an aneurysm right now because there's no way any of that is possible. Based on my understanding of the world 25 years ago, none of that is possible. That's unbelievable. But at the same time, imagine taking this and showing it to somebody 25 years from now and saying, this is the best in technology we have to offer right now. Imagine showing your phone to somebody 25 years from now and saying, I paid $800 for this. And they'd be like, is that a screen? Why is it so big? Why is it just sitting there? Why isn't it like, flying around or whatever they're going to do in the future? We are on a continuum of technology, and to prove it, I vividly remember begging my parents for some of these video games and telling them, Dad, you don't understand. It's a racing simulation. It is so real. It's like driving a car. It's like playing football. And me and every kid in 1992 wanted these games because the graphics were so amazing. That's why we needed the Genesis and not the Super Nintendo, because this one had like blast processing, whatever they were calling it. Whatever we are at now is going to be eclipsed by something else. And eventually the games that you are buying that are like the games that you buy now will show up on some sort of box in a mall as a retro game. And that's when you'll feel as old as I do now. We are on a continuum. And just to really think about this, we need to think about the way that we used to do things and the way that we're going to start doing things. And this is where we're going to get into some of the topics we're going to cover today. In the past, on classical computers, doing things the old-fashioned way, if we had a bunch of companies working together where they needed to share data and update data, not just read it, but update data, the only way to do that was really forms and contracts and approval processes and lots of time. Okay, well, maybe you're partnering with another college and an education system, and you need to agree to this group curriculum you're working on. You'd have to schedule bi-weekly meetings and get together. Do you agree to these updates? I see you made these updates. We don't agree to those. All this process, all this back and forth. Well, in the business world, you can't always have those face-to-face or even WebEx-style meetings. We're going to have to do something programmatically. And that's where blockchain comes in. What if we make this idea of negotiating a shared ledger something that we can program? And sometimes moving forward means some of the stuff that we have as our current state of the art we abandon, take a step back, and move this way, because this way has more headroom to go in. Anytime a new piece of technology comes around, especially a lot of the technology we're talking about here, there's people who are going to get really upset because the stuff that they've got really used to all of a sudden isn't quite as relevant anymore. So that's that pushback of let's not make anything any more complicated anymore. What if I run a business and I have a couple of warehouses all over the state, and I need to know who's coming and going, driving their vehicles in and out of those warehouses. And I just want a report at the end of the day that says at this time, this kind of car or truck or whatever or person came into this building with this license plate. And I want to automate that. Well, without artificial intelligence, the way that we would do that is we'd have a whole lot of manually programmed rules. You'd have to hire a programmer probably for years to sit down and write a whole bunch of if this, then that, else statements. Is the thing more tall than it is wide? Then it's probably a person. Does it have 2, 4, or 6, or 8 roundish looking things at the bottom? Then it's probably a vehicle. Does it have 3 on one side? Then it's probably a truck. Okay, let's start looking at the license plate. Let's find the license plate first off. Is this a 7 or is it a T? Okay, well, I'm going to write a rule that if the thing that goes up and down the most is slanted a little bit, then it's that's the old way of doing this. And people did write image recognition software this way. It was incredibly tedious. And it was less about the data, more about the programming behind it. Well, what if we use the data that we have to train a model, which is kind of like a byproduct of a program to do a lot of that work for us? And it means abandoning some of the work that's been done in these previous methods, but now we have all sorts of artificial intelligence and image recognition frameworks and languages we can use. This is the way forward for artificial intelligence. What if I happen to work for a large packing or package shipping logistics company, right? And I have all these, autonomous vehicles, I'm thinking future here, that are delivering packages and picking them up and doing all sorts of stuff all throughout the day. And the world changes on a minute-to-minute basis. There's traffic over here, there's weather over here. This shop is going to close early, this shop is going to stay open later. There's a weather system coming in. Stuff can change up to the minute. And how do I optimize the routes of all of these vehicles minute by minute so I'm getting the most efficiency? I'm not sending 2 vehicles to the same place and having only one of them come back with a package. Well, the old way of doing this, if somebody were to do this, would be massively iterative. I'd have a whole bunch of models that are close fits, and then I'd test them all out, which takes a ton of compute time. Does this work? No. Does this work? No. Does this work? Well, this one worked better than that one. Okay, let's evaluate this one against this one. Massive amounts of compute time, and by the time you got an answer, those vehicles are 5 miles down the road. So not very good, not a good solution. And this is something where quantum, who knows what quantum is ultimately going to do? There's a whole lot of possibilities, but one of the promises of quantum is that we can run multiple simulations at the same time. It's completely outside of classical computing. And some of the detractors of quantum computing will say, yeah, but until it can run a standard C program as fast as a regular computer, it's no good. Well, we're not going to write programs the same way we write them in a classical computer. It's a completely different set of tools. It's like we landed in another universe, and we need to build a whole new toolbox, right? The stuff for quantum, it kind of, in some sense, shadows or mirrors the classical computing and mathematical styles, but in other ways, it has its own different set of specialties. So this is a really interesting area to look into, especially because there's work being done in the hardware side, like how many qubits can we fit into a physical machine, as well as in the mathematical and theoretical side of how do we write mathematical applications to take advantage of them, as well as on the software architecture side of what frameworks and libraries and programming languages can we use to take advantage of all these. So this is such a hot area right now. It's something definitely with a whole lot of legs. One of the common threads here is really in how do we grow something from something that works great on my computer to something that can run on a worldwide scale. And if you've ever, who here is like a computer science student? So you've written programs. You ever written like a really dirty program that it works, but just by the skin of its teeth? Like if somebody were to put in, it's expecting a letter, but if somebody would put in a number or like not put in anything at all, it would just like completely break itself. Or if like 2 of the same programs were accessing the same data at the same time, like who knows what would happen? When you start thinking about those kinds of things, those are scaling issues. And that's where enterprise technology gets really interesting. And that's the kind of work that we get to do with big companies, like Walmart, Fidelity, UPS. They are solving problems at such a broad scale. It's stuff that can't ever go down. It's stuff that needs to be able to scale. And they are very interesting challenges. So I always think about that's a cool solution. How will that work when there's 80 million people using it at the same time? Or do we have to go back to the drawing board? And I was thinking about how can I relate this back to a real thinkable, relatable situation. And I see a Master of the Mainframe shirt back there. Who in the room has done Master of the Mainframe? I see a couple hands. Good. So I was on the team that helped get Master of the Mainframe off the ground 16 years ago. And it was very, very, very grassroots 16 years ago. We basically asked for a little bit of money, which we thought was a whole lot of money, but in terms of, to run a worldwide promotion, it's like, really? You only want a couple $1,000s? Yeah, sure, here. The caveat was that we had to do everything ourselves. So we didn't hire an external company to do the promotions. We ran everything on our own system with our own sysprog, keeping track of everything as a side gig. And more importantly, we had to ship out everything by hand. So we had what was called an annual shipping party, because if you called it a shipping task, nobody would show up. So we say, hey, we're throwing a party. It's a shipping party. It's a shirt packing party. So what we did was we all got together in this one room. It was like a little bit smaller than this, a couple tables in it, and there was all the shirts, because if you finished part 1 of the contest was small enough where we could give everybody who finished part 1 a shirt. You also got a certificate with your name on it saying that you finished part 1 of Master the Mainframe. You also got like a nice letter saying, hey, thanks for doing this. And all that went into a padded envelope with your name and address on the front of it, sealed with tape, and it got shipped out to you. And every single one of those was we did by hand. So the process is you go over to the list of everybody who would get something. You find the first name, cross it off, go find their shipping label, go find the appropriately sized shirt, because it also said like their name, their address, and their shirt size. Get the right size shirt, find their certificate out of another box, find a letter. I think the letters were generic. Put that into an envelope, seal it shut with a piece of tape, put the shipping label on the front, throw it in the box, and start all over again. And once you kind of got used to the flow, I think it took maybe a minute from beginning to end. And that's assuming that it wasn't one of the students who finished in the day or two prior to the packing party, because we had to run off all these certificates a week in advance. So the ones that we did in the week before were in another box. So if you couldn't find it there, you had to look in another one. Anyway, that was the process. And it worked fine if there's one person doing it. So some people show up to work really early. They might start packing these boxes at 7 o'clock. Eventually another person shows up. Hey, can I help? This looks like fun. Yeah, sure. Here's the process. You find the name on the thing, you cross it off, you find the right size shirt, the label, everything, put it together, put it in the bag, send it off. Okay. And 2 people can work at the same time doing this thing. And it might be a little bit less than twice as fast as one person doing it, because every once in a while, you might be going for the same shirt box or something like that. But more or less, it's twice as fast as one person. An hour later, 2 more people show up. So now you have 4 people in the room. And now you're running into more of those situations where you're waiting behind somebody who's maybe waiting behind somebody to get to that list or to get to that tape. Hey, while you're tearing off that tape, can you tear me off one too? I need one. Well, now it's time to think about the architect of scale. How do we grow this faster? Because if any more people show up, it's not going to be, if there's 8 people in the room, it's not going to be 8 times as fast as one person, right? We can't grow this any further without saying, stop, let's take a step back, let's re-architect our solution and think about how this thing is going to scale. The process is great. The process is great when it was this big. But now we've got 8 people. How do we grow this thing even more? And that's when you have to start thinking about specialized tasks and processes. Okay, you're the tape person. Your job is just to sit there and rip off 9-inch pieces of tape and put them on the side of the table so people can grab them. Fantastic. You're in charge of names. Actually, 4 more people showed up. Okay, you're in charge of names A through M. You're in charge of names N through Z, and so on. So you start finding these opportunities to kind of specialize things and re-architect everything for scale. And you know what? It really makes you think about, how do we take a program or a solution that worked fine in a vacuum, worked fine on my PC. I wrote an app. It works fantastic. It connects to a database and does a thing. Well, what about when there's 800 or 8,000 instances of this app out there, all trying to access the same database at the same time? Uh-oh, it's time to re-architect this thing for scale. I was actually digging through the archives to find this. That's me, I think 12 or 13 years ago, after packing a day's worth of shirts. You can see a UPS box over there. But yeah, so many shirts, and the process had to be changed multiple times throughout the day. Otherwise, it just never would have happened, and it involved a couple trips back to the drawing board. So as you hear about all the technology that's going on today, quantum, blockchain, AI, just know that this is not the goal. This is the next step. And this involves somebody saying the existing technology that we're using is not going to cut it anymore. We need to take back up a few steps and go another way and try to make this happen. And realize that there's always going to be this tendency, or this, you're going to want to stay in bed. It's comfy here. The pen is all the way over there. And sometimes, especially once you learn your first piece of technology, learning that second one, it seems a whole lot harder because you have to get rid of something you already learned. But in every one of these cases, the new technology is able to do stuff at a scale that the old technology simply can't. And I find it very exciting. I hope you guys do too. We have some great speakers, and I'm so thankful that you let us come down here and do this. This is going to be a fantastic day. So thank you very much.